A mole is the amount of substance that contains as many particles as there are particles in 12 grams of carbon-12. I rather prefer to define the mole as a group containing 6.02 times 10 power 23 particles. This is Kagenda Kenneth for Chemistry at Heart. From the first definition, the mole is defined as an SI unit and is most commonly given a formula or abbreviation of mole. The second definition seeks to also portray the mole as a group, and this makes the SI complete. For example, just as one would say that 1 meter is a group containing 100 centimeters, then a mole is a group containing 6.02 times 10 power 23 particles. So you may be wondering how a mole is converted to grams. It is only possible if you know the R.A.M of the element which you seek to deal with. For those of you who don't know R.A.M, I already covered it in my previous video, and I listed R.A.M of all the commonly dealt elements, which can also be found on the periodic table. So before any conversion is made, one should know that the R.A.M of an element is the mass of 1 mole of the same element. That is, R.A.M is the mass of 1 mole of an element. What do I mean? Let's look at that example and see what I actually mean. Calculate the number of moles in 89.99 grams of silver. Then when we open brackets, we're seeing that they've written Ag is equal to 108. Ag is equal to 108 that has been written in brackets is actually the R.A.M of silver. And this means that 8 grams of silver contains 1 mole. I get this statement from the fact that R.A.M is the mass of 1 mole of an element. And if we know that, we can proceed and say 89.99 grams of silver contains 1 divided by 108 times 89.99 moles, which gives us 0.83 moles. For those of you that don't know the order I'm following during the multiplication in brackets, I refer you to my previous video about relative atomic mass explained. Let's look at another example. Calculate the number of moles in 8.35 grams of lithium. Then they open brackets and say Li is equal to 7. 7 grams of lithium contains 1 mole. 8.35 grams of lithium contains 1 divided by 7 times 8.35 moles, which gives us 1.193 moles. Again, I refer you to my previous video, the mole explained, if you don't know the order I'm following in brackets and why I'm writing grams before I write moles. Example 3 is just about the same thing. Calculate the mass of 0.5 moles of sulfur, and then in brackets they tell us that S is equal to 32. This time we are going to begin with moles on the left and then grams on the right, because it's actually the grams, in other words mass, that we are looking for. 1 mole of sulfur weighs 32 grams. 0.5 moles of sulfur weighs 32 divided by 1 times 0.5 grams, which brings us to 16 grams. Example 4, calculate the mass of 2.35 moles of sodium, and in brackets they tell us that sodium is equal to 23. So this means that 1 mole of sodium weighs 23 grams, 2.35 moles of sodium weigh 23 divided by 1 times 2.35 grams, which actually brings us to 54.05 grams. I think right about now it's very evident that the figure that is always given in brackets is actually the relative atomic mass of that element. And there are some actually complicated examples on this, especially when you're given a compound in the question rather than an element, as we've been seeing in the previous 4 examples. Let's look at example 5 to drive this point home. Calculate the number of moles in 4.4 grams of carbon dioxide. Then in brackets they tell us C is equal to 12 or is equal to 16. This question is different from the previous 4 examples, because in the previous 4 examples we've been dealing with elements, and it was actually easier to just use the figure given in brackets and relate it to 1 mole. But this time we're dealing with a compound and the figures given in brackets are more than 1. This problem is done about with if we know the formula of carbon dioxide, which is CO2. Then after knowing the formula of carbon dioxide, we should know the individual atomic masses of carbon and oxygen. If we know the individual atomic masses of carbon and oxygen, then we just have to add them together to come up with what is known as the relative formula mass. Relative formula mass is almost the same as relative atomic mass, and the only difference is that relative formula mass is the mass of compounds, while relative atomic mass is the mass of elements. So to get the relative formula mass of a compound, you just need to combine the relative atomic masses of the individual elements present. This means that the relative formula mass of carbon dioxide is 12 times 1, because carbon is appearing once, plus 16 times 2, because oxygen is appearing twice, and the 16 is actually the atomic mass of oxygen, 12 is the atomic mass of carbon, and that brings us to 44. So meaning 44 grams is the relative formula mass of carbon dioxide. This means that 44 grams of carbon dioxide contain 1 mole. 4.4 grams of carbon dioxide contain 1 divided by 44 times 4.4 moles, which brings us to 0.1 moles. Let's look at example 6, which is just about the same thing. Calculate the number of moles in 51 grams of sodium chloride. Then in brackets they tell us Na is equal to 23, Cl is equal to 35.5. The R.F.M of sodium chloride should be got first, and this is 23 times 1 because sodium is appearing once, plus 35.5 times 1 because chlorine is also appearing once, which brings us to 58.5 grams. So meaning R.F.M of sodium chloride is 58.5. We shall begin and say 58.5 grams of sodium chloride contains 1 mole. 51 grams of sodium chloride contains 1 divided by 58.5 times 51 moles, which will give us 0.87 moles. So this brings us to the end of today's video. Hit the like button if you find this video awesome, and don't forget to subscribe. This is Kagena Kenneth for Chemistry at Heart.